Hey everybody, welcome back to AWS What's Next. If you're just tuning in, this is your opportunity to learn more about some of the latest features and services that we launched at reInvent. And in this stream specifically, we'll be talking about new monitoring capabilities with Amazon SageMaker Debugger. To tell you all about the new features and capabilities in SageMaker Debuggers, I have here with me Satadal. Satadal, do you want to go ahead and introduce yourself?
Yeah, absolutely. Thanks, Sasham. My name is Sadadal Bhattacharjee. I worked in Amazon SageMaker product, and I work closely with customers to help them use machine learning in their use case through SageMaker. And I'm excited to talk to you about the feature that we just launched yesterday, a new monitoring and profiling capability in SageMaker Debugger.
Awesome. So, welcome, Satral. Very happy to have you here on the live stream. So, let's quickly recap for our users. So, back in 2019 reInvent, we launched Amazon SageMaker Debugger, and we had a lot of debugging capabilities for machine learning training. We were able to monitor rules. We had all these capabilities to help improve model performance and early stop when the model was overtraining or underfitting and so on. So this year we've enhanced capabilities of SageMaker Debugger, and we've added new profiling capabilities. So if you're as viewers, if you're just starting to use SageMaker Debugger, we've drastically enhanced new profiling and monitoring capabilities that we'll talk about in this stream. We'll also see a live demo. But before we jump into the product, Satadal, do you want to start off by talking about what were some of these profiling and monitoring challenges that customers were facing, that they were telling you that this is hard to do when training machine learning models at scale in the cloud?
Sure, absolutely. So when we talk with our customers, right, they say that, hey, SageMaker Debugger is great. It's helping me find non-converging issues like my gradients becoming too
Mm,
large or too small when they're training deep neural networks, or the losses not decreasing and so on. And they can
mm,
also stop their training early and not waste compute and time if they want through the built-in rules that we incorporated in Debugger. But at the same time, they were saying, wait a minute, I still don't have a good way to understand how my CPU, GPU, network, IO memory utilization looks like. And as we all know, GPU is the most expensive, usually the most expensive resources. So the data scientist wants to know whether they're optimally using the GPU or not. And especially the machine learning operations
mm.
that they're use in their training script, are they executing on GPU or not? By mistake, are they executing
Right.
in CPU that leads to longer training time? So we took that very seriously. And this year, I'm happy to announce that we came up with the monitoring and profiling capability, which addresses exactly that. It takes away all the undifferentiated work from our customers and data scientists in terms of going and collecting
Mm.
those metrics. We do all of that. They don't have to change even a single line of code in order to emit the right kind of metrics and data. And in addition to that, we also generate a detailed report and visualization.
Nice. I can tell you, I totally resonate to that challenge because if you're using the latest version of TensorFlow and you're training your models, if it's slow, you almost never have any idea of how much CPU is being utilized, how much GPU is utilized, especially if you're using different data augmentation schemes and so on. And if you really want to check on a single machine, you can pull up some different profiling libraries from NVIDIA and Intel, but it's really not that seamless, and it's so much more harder when you're doing this at scale on a cluster. So I totally resonate, and I'm really looking forward to this
Absolutely.
capability and the demo that you're going to show towards the end. uh,
Sure.
but let's talk about the challenges a little more. How were customers addressing this today before this new
Mhm.
capability? what
Right.
what were they doing? What are the steps that they were taking to address this?
So what we have found while talking to customers, right? What they have been doing is they use a diverse set of tools, a combination of open source tools, and also if you look at Amazon console, you'll see that we have some kind of utilization metrics
Mm,
that we give in CloudWatch alerts, which are
right.
aggregated over time and doesn't have enough granularity. Usually, it's around 1 minute granularity. So
Mm,
while there are ways in which you can get some of this data, it actually takes time away from data scientists, right? When their focus is more around training, they now have to deal with understanding the details of how to use an open source tool in TensorFlow if they're using TensorFlow, and then for some other reason if they're using PyTorch, then they have to go off and understand how to profile their training with PyTorch and so on and so forth, right?
Right.
In addition to that, they also have to understand the details of if they're using NVIDIA GPU, how the CUDA library works, and so on. So what
Mm,
we did was we created a uniform API layer and uniform interface and a report by which all of that details or undifferentiated work, as we call, is taken away from the data scientists so that they can get those matrices already bubble up to them in form of report and visualization. And all
mm,
they do is they use API to fetch the data. The API is uniform; it doesn't change. We support TensorFlow, PyTorch, so it's uniform across the two machine learning frameworks, and it also takes away the actual understanding of the details on how to run the commands, right? Being a
mm.
managed service, obviously the customers expect that we handle that, and they are freed up to focus on their own problem, which is basically convergence and better accuracy.
Right. So I think that the fact that you're removing the undifferentiated heavy lifting, that's the key important point here, because it's not like customers weren't able to do this, but as Andy mentioned in his keynote, most organizations use more than one framework, and having to learn all these separate toolkits for TensorFlow and PyTorch and MX and probably something else, and also not being a hardware expert as a data scientist,
Right.
and not being an expert on GPUs or networking or CPUs. These are things that you as a data scientist or a machine learning engineer don't want to be spending time on. It's not like you can't, but this is not where you're going to be productive when, rather than focusing on solving a machine learning problem. So that's I think that's spot on, and like I'm excited to start using this. So could you tell a little more about the new capabilities that was launched? What specifically was added to existing SageMaker Debugger? You mentioned some of these things, but could you talk about the developer experience? So how would a developer get started with this and start using these new monitoring and profiling capabilities?
Yeah, absolutely. So to get started, the data scientists usually, first of all, in order to start training, they will usually use a notebook. And in
Mm,
that notebook, as they are training today in SageMaker, they will have most people use script mode, which is basically using the Python SDK on SageMaker. So on the estimator function that they have, usually they're just enabling certain functionalities if they want to customize it. By default, SageMaker Debugger will already collect the system resource utilization, which is CPU,
mm,
GPU, network, IO, memory. So for that, there's no change required. And the loss and accuracies are also collected by default. But the customer has an opportunity to go in and configure. They can say that, hey, I want detailed Python profiling, like all the
mm,
Python functions that they're using in their training script. If they want to track on how much time they spent, they can do that. They can also say that, hey, I want to focus on the data loading part. So I want to get more details on that. And they can also time limit it. Like instead of getting
mm,
all of this profiling data across the training job, especially if the training job is long, then they can say, I
mm,
want to only start from X number of step and go for a specific step duration, right? Or they can time limit it based on a time duration. Like I want to run the profiling only for 5 minutes or 10 minutes. If they want to do that, they just go in and configure the profiler. They can do it in two ways. Either they can go into their script and change it, right, using the API
mm.
as I mentioned, or they can go to Studio if they're using SageMaker Studio and click on Configure Profiler, and then they can change it, right? So it's very simple to use. And all of the work in terms of standing up separate containers, analyzing the data in real time is all done by us. The SageMaker Debugger does the analysis outside of the training container, so the impact to the training is reduced. The only impact is during emission of data. So obviously, if the data scientist wants to emit at every step or all of the metrics, then they will take a hit in performance because of the writing into the volume. But in terms of the analysis, report generation, visualization, these are all done outside of SageMaker training container, right? So that's the main thing that we have done is there are a few things, right? I would articulate in such a way
Hmm.
that the amount of data that is being emitted, especially when you are trying to profile, can be huge because most of
Right,
these machine learning operations happen in microseconds. So if you
right.
go up and say that I want to profile for, let's say, 10 minutes or 20 minutes or even the entire training time, then the volume of data that is being generated can
Mm,
overwhelm. So we have seen people using other open source tools and they complain that, hey, I go out of memory and
mm,
I have to limit my profiling to a couple of steps or 4 steps, and it's not sufficient to know what's going on. So we have actually dealt with the whole orchestration of managing the volume for them. So we do it behind the scene. We have also taken away the task of standing up separate containers, running the
mm.
analysis, and then generating report, right? So the whole infrastructure and management is completely gone, right? And the actual data that is required to do the analysis is also taken care of.
As you were talking about how this works, I was just thinking about so much of the heavy lifting is taken care of because managed service. For some of you who are new to SageMaker, you just bring in your training script, which is what Sartadal described as script mode, and um, training resources are automatically scheduled and they run. But with this new capability now, the monitoring capability runs on a separate container, so you're not actually modifying your own training code. And
Right.
the nice important thing you mentioned is the data that's captured. If it grows as it grows, as you train larger models, it's automatically copied onto Amazon S3, right? So you can actually query it as it's running and plot um, charts on how the utilization looks like. But you also mentioned that these charting and reporting capabilities are also integrated into Studio, right? So you,
Right.
as a developer, you can, if you want, generate your own charts, but you can also just utilize what's automatically available in Studio with visualizations, which I know you'll show in a demo. I'm excited to see as well.
Absolutely. So I can switch to the demo and show, but just before that, I just want to mention that, yeah, so the ability to control the time interval is up to the user. So you can go all the way down to 100 millisecond time interval,
Mm,
or you can go up to 1 minute. And there are 6 different options in between. Obviously, the lower the granularity, the more insight you get, especially when customers are looking for spikes in GPU or CPU utilization or network utilization within a very small
mm,
time window, they can do that. And all of the data that we collect is in persistent S3 bucket. So it's in their secured S3 bucket. So the customer has full control over it. And they can go back and look at the data even after training has completed, so that once they deploy the model and they come back, they can utilize that. So let me switch to the demo, right? And let me walk you through some of the key things that we have done. As you can
yeah,
see
let's do
here,
it.
I am showing SageMaker Studio. So this is how Studio looks like. And there is a tab right here called experiments and trials. So all of the training trials that you do are grouped under experiments. In this particular case, I have not named my experiments, so they go under unassigned trial. But if you name it, then you'll have your own experiment. And I have run a training job ahead of time for this demo. As you can see here, it's a PyTorch model, single node. I have not done distributed training. Obviously, the debugger supports distributed training. And once
Yeah, and
the
Satyal,
training
for
is
some of our viewers who are new to experiment, so a trial is there may many trials part of an experiment, but a trial is one iteration of a
that's right.
training run, right? One
That's
iteration.
absolutely correct. One iteration of a training run. And usually what data scientists do is they change their hyperparameter values and do
Run
multiple
many such
iterations.
iterations. Right.
Yes. And then they look at many things like losses not decreasing and how accurately the model is training. That's absolutely correct. So in this particular view, which we call as debugger inside view, the way to get to it is if you have a training job, just like the way I have here, you can right click on it. And basically it has options for open debugger for insights and open in trial page. So I've already opened the debugger insight right here. And you can see that if the job was running right now, this configure profiling will be enabled. So you can click on it and it will have the option to adjust the interval, as well as allow you to go into fine granular metrics, as I mentioned, like Python profiling, data loader, and all that, and change the start and end time. So you can do it at any point throughout the
Mm,
training. Especially with deep neural networks, the training can run for days and
Right.
even weeks. So it is good for a data scientist to be able to see the insight without having to wait for the training to complete. So we'll give this view as well as the report that as talked about. You can download the report as soon as it's and training starts. Obviously, at the end, you will
Mm.
have the complete report, but nothing prevents you from looking at it when the training is going on, right? So let me give you a quick overview of what we
So,
are
so
showing here.
Satyendra, I think
Yeah,
something you mentioned, and I want to emphasize this. A developer or data scientist can get this view with zero code changes, right? If they're using TensorFlow or PyTorch,
right.
they just run their training as they normally do, and the profiling and monitoring capabilities are on by default, and they'll get this by default, right?
Yeah, so the part that they will get by default is the system resource utilization. So
Mm.
the first part here, the training job summary will be there by default because it is based on the system resource utilization that we collect, right? Which is
Yeah,
CPU,
that
GPU, network,
that itself
IO.
is so helpful. Yeah.
Yes, and the reason why it's helpful, Shashank, is that if you see that your initialization time is significantly
Mm.
higher compared to your training loop time, which shows that during data prep time, it took a lot of time to ingest the data and prepare it before training started,
Right.
right? So
Right.
right there, by looking at this pie chart, you can say that, oh, wait a minute, I think I have a problem here. And you
Mm.
can correlate that with some of the insights that we are providing on the right side. The insights are basically the analysis that we run on the training script. And the part is basically a bird's eye view of what happened during the training. This part is basically a bird's eye view of what happened during the training.
Mm.
If you're using, for example, spot instances, it'll show spot interruptions. And if you stop and start the profiler, it also shows that. And if you look at the part bottom, just below that, if you're using distributed training and have multiple instances, all of those nodes will be listed here. And for each of the node, you will get an overview of your P99, which is the 99 percentile
Mm.
of usage, P95, P50, and so on, of your resource utilization, right? Which includes CPU, GPU, network, and then CPU memory and GPU memory. So at a quick look here, you can say, wait a minute, my GPU looks like it's only utilized 12.5%.
Mm.
That is really low utilization. And you
Right.
can correlate that with the insight here, which we also detected that your issues
Uh,
found that your GPU is low utilized, not fully utilized. And it shows that over the period of training, 80 times this rule triggered. And the way
mm.
it triggers is through these thresholds right here. The P95
Okay.
percentile, if it's below 70%, we basically triggered this particular rule, right? So
Mm.
this kind of things is useful to the user because at a quick glance they can understand what's going on without having to go deeper into backend analysis.
It's nice that you not only provide the raw information on the left, but also the insights. I think that's super helpful. And a developer can change these thresholds, right? They can
That's
decide
right.
when the rules can be triggered.
Absolutely. So if you want to change the threshold, then what you do is when you, in your training script, you specify the threshold in your estimator function in the
Mm.
profiler config. I'll show in a moment, and you can configure it to the way you want.
Awesome.
Otherwise, if you don't say anything, the defaults will be used. And there is documentation which they can click and learn more about it. Okay. Now, if you don't go with the default system resource utilization, you can configure the profiler in your script to say that, hey, I want to collect what we call as framework metrics. The framework
Mm.
metrics are basically where we go and start looking at which operations executed from your training script and how much CPU and GPU time did it take, right? So you get a much more granular view of your training job and the individual functions that executed, which machine learning operations they used. So you will know at a quick glance
Mm.
what happened. Like, for example, in one of our beta customers, they were using a function in their training script which they were expecting to run on GPU, but that ended up running
Mm.
on CPU because of some issues in their code. And by looking at a quick glance, they immediately correlated that, wait a minute, this operation is not executing on GPU. As a result, their training was taking longer and the GPU
Mm.
utilization was low. So with this kind of data, you can immediately get to those issues, right? And
Right.
then there are some other insights that we provide. So let me quickly, in the interest of time, show you the other part of this view before I jump to the report. So you also have an option to go into a per node view. So right now I have only one training instance. So under the training instance, we show CPU, and network utilization right here. These are interactive graphs, so you can basically zoom in and zoom out. You can also select individual core count, like each of the CPU cores, or you can look at the mean. The default is main here. You can also look at GPU utilization right here. So here in this particular training job, as we just discussed, the GPU utilization is pretty low, and you usually want it to be high. You can
Right.
also look at individual GPU cores. Like, wait a minute, GPU 0 seems to be way more than the other ones. In this case, it was
Mm.
not uniformly utilized. And we provide a heat map. The heat map we found to
Right.
be very useful. At a quick glance, you can see that this particular training instance, we're using 64 CPU cores, right, and
Ah,
eight different
okay.
GPU cores. So you can see that the darker the color, the more utilization based on this legend right here. So
Mm.
this overall training instance, you can see that it's mostly light color, which shows that the resources were not utilized
Yeah.
to its fullest extent, right?
This would be my first go-to graph if I, I mean, I can see here that only one GPU is being utilized, and
One,
that's wasteful for all the. So you may decide after seeing this that you want to run this on a single GPU instance instead, or figure out how to use all four
or
GPUs.
increase batch size. You increase batch size, for instance, to utilize your
Yeah,
GPU
and
better.
even the CPUs, maybe you can use a instance with the fewer CPU cores or do more data augmentation so you can utilize. This is
Absolutely.
fantastic. I think that's my first go-to graph before I see everything else.
All right. But you can also, the other thing that we try to do is basically if you see a GPU underutilization or a bottleneck kind of conditions, you can drill deeper in terms of what was going on in your training script at that time.
Mm,
The
mm,
graphs below here, as you can see on the top, we are mapping both CPU and GPU utilization. These are interactive graphs. So I can say, hey, between this time window, what happened? So I can select the time window. And as you can see, the graph below that is changing based on that, which shows that within this time window, what was happening in my training script. So here you can see this is forward propagation, backward propagation, and it shows data loading as well. So in this time frame, the data
ah,
loading happened. So it helps you correlate your resource utilization with what was actually going on in your training script to find bottlenecks quickly, right? We also show this time on each of the steps, so you can hover your mouse over and see. Um, in addition to that, we provide this detailed report. As you can see here, download report. So I already downloaded here and I opened it. The
yeah.
report has more details. It obviously has the training summary, user statistics, as in the overview page, but it goes beyond that and starts looking at how much of your time was spent between CPU and GPU,
Mm.
and also breaks down the actual
All
operations
the
that
ops.
executed in CPU
Yeah.
and GPU, right? So you can basically drill deeper and understand whether these are the functions that you executed or intended to run on CPU and
Mm,
GPU. Like I gave you the example of the beta customer, right? By looking at that, they were
right.
like, oh, wait a minute, and that helped them a lot. And it gives you a summary of the rules. These are insights that you saw on the overview page. The report actually groups them together, and here you can see in
So
this
not
particular
only can you
case,
see them live, but once you have a report, you can
offline.
actually file it or share it with someone. This is great.
That is correct. That is absolutely correct. And then once we find these issues, we obviously go deeper and give you much more detail on each of the issues found. There are additional charts. So you can drill deeper, and once you start going through it, you'll get a better understanding what happened, which led to it, right? And how do you optimize it?
Yeah, I see the same result here with the GPU 0 being utilized fully. I think something else that jumped out at me,
Mhm.
which I didn't realize earlier, was the fact that you can get all these individual metrics, but with debugger new capabilities, you can do the correlations as you mentioned. If such
That's
a
correct.
if such and such an event happened here, how does it relate to what's happening in my code? I think that is very powerful because it's easy to look at different numbers but not know how to fix it. But now when you see the
That is correct.
cause and effect and the correlation, I think that's more actionable for a developer to go and fix what's wrong with the script. I think that is really powerful.
That's absolutely correct. And that's exactly what our customers have been asking as well. that just don't just throw the data at me, because there are a lot of ways in which I might be able to get the data through open source and stuff.
Right.
But actually finding out where the bottleneck is and fixing it quickly is what they are looking for. And that's what we took very seriously. And I also forgot to mention that these alerts, the insights that we are getting here, you don't have to wait for the training to complete. You will get CloudWatch alert events. So, for example, if you go into the describe trial component by right
Mm-hmm.
clicking on your training trial, you will also see this kind of alerts come up. So, in my case, I had enabled loss not decreasing, vanishing gradient, and
Right.
rate update ratio. And as you can see, the vanishing gradient triggered in this particular job, right? And it said that, hey, your gradients are becoming too small. So you
Mm.
get this kind of alerts throughout. So especially for a long running training job, if you see serious issues come up, you can either just go and quickly stop the training right from studio itself, or you can right here the stop training. When the training is going on, this will be enabled, so you can stop it, or you can configure the CloudWatch alert to automatically stop the training for you using a small Lambda function. So that
That's
saves time and
great for automating and catching and making sure you don't um, use resources or waste resources if something's not
that's
working
correct.
as planned. For a developer who wants to, start using all this, what frameworks are supported? How can they start using this?
Sure. So to get started, basically we support both TensorFlow and PyTorch, and all you have to do is bring your training script to SageMaker, and you can start training immediately. And by default, as I mentioned to you,
So
the
zero
system
code
updates
changes, right? If you want the default.
is zero code change. Let me quickly show you the training script just to be clear. If you want to configure things, here is how you do it. You
Mm,
basically import the SageMaker Debugger library. So we also have what we call SM Debug library that we created with the debugger. It's an open source. It
mm,
gives you all the functions and APIs that you need to fetch the data from S3 into NumPy array, and you can do your own custom analysis in Notebook, right? But in
mm,
this particular case, what we're doing is we are importing the profiler rule and the rule config, and we are basically specifying what rules we want to run. Rules are basically the analysis that you saw being triggered, right? So in this case, I can specify any of the built-in ones. So we provide around 20 odd rules, but you can also specify your own analysis by writing your own custom rule. It's very easy to
And
do that
these
in
rules
open
run
source.
as separate services. And these rules run as separate services that monitor your training
Right.
job, right?
So the way they
Outside of your
run,
training.
that's correct. The way they run, Shashank, is that we set up separate container. I would not say service. It's basically separate containers, and
Uh-huh.
inside that container, which we call rule container,
Mm,
the rules run. So it's not impacting your training, which the training is happening in a separate container altogether. So you're absolutely right. We stand up and manage that container on behalf of the customer.
fully manage that.
Yeah, and also for running the built-in analysis and rules, there is no additional compute charge passed on to customers. That is all
Mm,
paid for by the managed service. They only pay for the actual compute consumed by
training.
their training.
Mm, okay.
Yes, that's correct. So as I mentioned to you, I just wish to here just to show you how easy it is to configure. So for example, if I want to change this interval, I can do it either from here using code. So I can say 100 millisecond, or I can say 6,000 or whatever, right? So there are three different
Mhm,
intervals I can select. And using framework profile, I can change what kind of framework metrics I want to select. Like for example, the data loader time, the Python profiling, and detail metrics, and I can specify start step and number of steps. So here, for example, this particular training job, I changed the number of steps to 10. If you don't say anything, it'll just do the default. And
mm,
default is basically every step it'll start collecting. Okay.
mm,
And the estimator function, if you're already using SageMaker, you must be familiar with it. For a PyTorch, this is an example with PyTorch. The additional thing you do is you pass the profiler config and you pass the rules. And that's it. You don't do anything in terms of how to collect the metrics. All of
mm.
that other stuff is taken care of on your behalf.
That is awesome. Uh, we saw so many different things here. We saw the new studio interface with the new graph report generation, and you also showed us the code changes, minimal code changes required to do this. Do you have anything else
Yeah.
that you have in the demo?
I
to
just have one more thing to point out that
yeah.
even though we have generated this report, we have heard customers say that, hey, this is great, but can I customize it
Huh.
and change it because I want to do some kind of customization, maybe change the range, change the color,
Yeah.
or whatever, right? So what we did was that along with the report, we also generate a notebook, which is this profiler report notebook. So from a data scientist perspective, they can either execute this as it is and they will get the same report, or they can modify whatever they want in terms of having more data, less data, or adding more to the report. And if they execute this, they're going to get a custom report generated as well. So
Oh,
we
so
wanted to make sure
you just
they
run
have
that
that.
notebook and you get the report. That is
That's
fantastic
right.
because maybe you don't need such a detailed report if you're sharing this with senior management. Maybe you just want to show the summary, or you want more details, so that's fully customizable. That's fantastic.
That's right.
Awesome. So Saturday, this was great. Thanks for the demo. I think this
Absolutely.
really clarified all the questions I had about how this service works. This is so hands-free. I'm excited to start using it. So let's talk about availability. Can I start with this today if I wanted to? Is this available generally? Can I
Yes.
start training and using this today?
Yes, SageMaker Debugger is fully available in all the regions that SageMaker is available, and you can start using it today. The only region that the profiling functionality is still not available is the China region, which will be available as a follow-up. But other than that, it's available in all commercial regions, ready for use today.
Awesome. So TensorFlow, PyTorch, ready for use today. Just log into your SageMaker Studio, start using it. Thanks so much, Satadal. That was fantastic. Thanks for joining us and walking us through the demo as well as talking to me about all the new capabilities. So there you have it, folks. That was the new capabilities in SageMaker Debugger for profiling and monitoring and all the other good stuff you saw today. So with that, thanks for watching. Thanks again, Sardar, for joining us.
Thank you so much.